Now in this lecture we'll find out the area of the orange shape. In the drawing we have square ABCD. One side of square ABCD equals to 10 units in its length. Inside the square ABCD we have two semicircles that intersect with each other. The first semicircle is DPC and the other semicircle is APD. They intersect with each other, and in this way they create the blue lens. A lens is the common area that is created by the intersection of those two lenses, and so they create the blue lens by the intersection with each other. And we also have the quarter circle ABQD. This quarter circle intersects with this semicircle, and they create this big lens by the intersection with each other. Okay, and our mission is to find out the orange area. Actually, the orange area, we can get the orange area by the subtraction of the big area, the big lens, minus the blue lens, gives us exactly the orange shape. So I'll write it down. So actually, the orange shape, the area of the orange shape, it is equal to the area of the big lens minus the area of the blue lens. We repeat again, the area of this blue, the area of this orange shape, it is equal to the area of the big lens. This is the big lens, minus the area of the blue lens. This is the blue lens. So the area of the big lens minus the area of the blue lens gives us the area of the orange shape. So I will present to you two different methods to find out the area of this orange shape. In the first method, we create general formula that gives us the area of any lens, and then we'll use the general formula in order to find out the area of the blue lens. We'll also use the same formula in order to find out the area of the blue lens. We'll subtract the two areas from each other. The area of the big lens minus the area of the blue lens, it is the area of the orange shape. This will be the first method. In the second method, we will find out directly the area of the big lens. We'll find out directly the area of this blue lens. We'll subtract the two areas from each other. And this will be the area of the blue lens. Okay? But before we start to answer the question. I will clarify two concepts. What is the area of this sector? What is the area of the green sector? The area of the green sector equals to the angle between his legs, that is theta, over 2 pi or 360 degrees. The ratio between the two angles gives us the relative percentage that this sector occupies out of the area of those circle, of the area of the whole circle, and we will multiply, when we multiply this percentage by the area of this circle, that is pi r squared, the result will be the area of this sector. Okay, so theta over 2 pi is the relative percentage that this sector occupies out of the area of all the circle, and then we will multiply this percentage by the area of the circle. It will give us the area of this sector. So theta over 2 pi times pi r squared is the area of this sector. I'll remind to you that 2 pi radians is 360 degrees. In terms of degrees, it is 360 degrees. Okay. The next concept that we will clarify is the area of a circular segment. The green shape is a circular segment AB, and the area of this circular segment AB will be equal to the area of sector AOB minus the area of triangle AOB. Okay? The area of sector AOB minus the area of triangle AOB gives us the area of this circular segment, the green circular segment AB. Okay? So we start with the first method, as I already mentioned. In the first method, we will create a general formula for the area of any length, and we will use this formula in order to find out the areas of the blue length and the big length. We'll subtract the two areas from each other, and this will give us exactly the area of this orange shape. So here we have two semicircles that are perpendicular to each other, they intersect with each other at 90 degrees, and the common area of the two semicircles is the length that we are looking for. Again, a length is the area that belongs to both semicircles. It is exactly this area. And we want to develop a general formula that gives us the area of any length. Okay? we will define the center of this semicircle as point O. This point is point L. We will define the center of this semicircle as point M. We define this point as point N. Here, point O is the center of this semicircle. Point N is a point on this semicircle itself. That is to say, ON is the radius of this semicircle, so we will define the radius of this semicircle as A. The radius of this semicircle equals to A units in its length. Here, point M is the center of this semicircle. Point M is the center of this semicircle. Point N is the point on this semicircle itself. Therefore, MN, line segment MN is the radius of this semicircle. We'll define the radius of this semicircle as B. Here, point M is the center of this semicircle. Point L is a point on this semicircle itself. Therefore, ML is the radius of this semicircle, that is equal to B units according to our definition. Actually, the radius ML is tangent to this semicircle at point L. Point L is the point of tangency point L is the point of tangency of tangent ML with this semicircle. Here, point O is the center of this semicircle. Point L is the point on this semicircle itself. That is to say, line segment OL is the radius of this semicircle, that is equal to A units in its length, according to our definition. So here we have the radius OL that is drawn to the point of tendency. That is to say, the radius OL that is drawn to point L, that is the point of tendency of tangent ML with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle equals to 90 degrees. Here, the radius MN is tangent to this semicircle. That is to say, point N is the point of tendency of tangent NM with this semicircle. And we have here the radius ON that is drawn to the point of tendency. That is to say, the radius ON, it is drawn to point N, that is the point of tendency of tangent MN with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent MN will be perpendicular to the radius NO. So if MN is perpendicular to NO, it means that this angle equals to 90 degrees. Okay? In the next step, we will join points N and L together by a straight line. We will join points O and M together by a straight line. The straight line NL divides the length into two parts. So we will find the area of each part, and this will be, we'll add the two areas together, and this will be the area of this lens. Very simple. Okay? So first of all, and this lens could be any lens. Okay? First of all, we'll find out the area of the upper circular segment, NL. Okay? We find out the area of the upper circular segment NL. So the area of this upper circular segment NL of the lens, that could be any lens, I will present it to you. What is the area of a circular segment? According to what I presented to you, you can easily see that the area of this upper circular segment, it is equal to the area of sector NOL minus the area of triangle NOL. The area of sector NOL minus the area of triangle NOL gives us exactly the area of the green circular segment NL. So I write it down. The area of sector NOL this is sector NOL that I copied from the original drawing. So we subtract the area of triangle NOL from the area of sector NOL. This is triangle NOL, and when we will subtract the two areas from each other, it will give us exactly the area of circular segment NL. This is sector NOL. I repeat again that the area of sector NOL minus the area of triangle NOL gives us exactly the area of this circular segment NL, the green circular segment. In order to find out the area of sector NOL, we have to find out the angle between his legs, angle NOL. So we'll define angle NOM as theta. Here, those two triangles can go into each other according to side rule. Why they can go into each other? Because those two sides, they are both equal to A, therefore they are equal to each other. Those two sides, in addition, those two sides, they are both equal to B, therefore they are equal to each other. And finally, side OM is a common side that belongs to both triangles. So this side equals to itself. So we actually found out that those two triangles can go into each other according to side rule. And for the fact that those two triangles can go into each other, we will conclude that those two angles, they are also equal to each other according to the rule that corresponding angles and congruent triangles are equal to each other. So if those two angles are equal to each other, and this angle equals to theta, then this angle must be also equal to theta. So in conclusion, angle NOL, this angle equals to theta plus theta in its size. So this angle equals to 2 theta. So now we can calculate, here we know that OL equals to A and O equals to A. So the area of sector NOL equals to the ratio between the angle that is between his legs, that is 2 theta, over 2 pi. This ratio gives us the relative percentage that sector NOL occupies out of the whole circle, and if we multiply this percentage by the area of the whole circle, that is pi r square, and r equals to a, so it is pi a square. This will give us exactly the area of this sector NOL. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, the area of sector NOL equals to theta a square and here we will not calculate the area of the triangle at all. In the first method, we don't have to calculate the area of the triangle at all. Okay, now we finished with the upper circular segment. In the next step, we will calculate the area of the lower circular segment. The shape in the green color, this is the lower circular segment, so we'll calculate the area of this shape. We will add the 2 areas together. This will be exactly the area of this length that could be any length. I'll remind to you that the length is the common area that is created by the intersection of 2 shapes with each other. In this case, it is the intersection, it is the common area that was created by the intersection of those 2 semicircles with each other. Okay, and our mission is to find out the area of this length. So in the second step, we will find out the area of the lower circular segment in the orange color. Okay, so the area of the lower circular segment this shape in the orange color, it is the lower circular segment. NL equals to the area of sector NML, this sector, so this is sector NML, minus the area of triangle NML. It's very easy to see from the drawing that if you subtract the area of triangle NML from the area of sector NML, you will get exactly the area of the lower circular segment NL. So here we have to find out the area, we have to find out the angle between the legs of sector NML in order to find out the area of the sector. So here, if we focus on the right triangle ONM, this angle equals to theta. This angle equals to 90 degrees, that is pi over 2 in terms of radians. So the missing angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in this right triangle to 180 degrees, this angle must be equal to 180 degrees, to pi over 2 minus theta. And those two triangles can go into each other, therefore they have, those two angles must be also equal to each other. So this angle must be also equal to pi over 2 minus theta. Anyway, you can see that this angle equals to theta, this angle equals to 90 degrees, that is pi over 2, and so this angle must be equal to pi over 2 minus theta in order to complete the sum of the angles in this triangle to 180 degrees. This angle must be equal to pi over 2 minus theta. So angle NML is the sum of those two angles. That is to say, it is the sum of angle pi over 2 minus theta plus this angle that is equal to pi over 2 minus theta. So here pi over 2 plus pi over 2 is pi, minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of angle NML, this angle, it is equals to pi minus 2 theta. Now we can calculate the area of this sector NML, because we know that the size of this angle, it is equal to pi minus 2 theta radians. Okay, so talking here in terms of radians and not in terms of degrees. So here, again, the area of sector NML will be equal to the ratio between the angle between its legs, that is pi minus 2 theta over 2 pi, 2 pi radians is 360 degrees. So the ratio between the legs gives us the relative percentage that this sector occupies out of the area of the whole circle, and we will multiply this percentage by the area of the whole circle, that is pi r squared, and r equals to b, so it is pi b squared. We get the area of this sector NML. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We'll open the brackets here and we'll get that pi b squared over 2 minus 2 theta over 2 times b squared. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, we found out that the area of sector NML equals to pi b squared over 2 minus theta b squared. As I already mentioned, we will not calculate the area of this triangle. We know that the area of this length equals to the area of the upper circular segment plus the area of the lower circular segment. Okay? I repeat again, the area of the length is consists of 2 circular segments, and the sum of the area of those 2 circular segments will give us the area of this length. Okay? So the area of this length will be equal to the area of the upper circular segment NL plus the area of the lower circular segment NL. Okay. And we have already found out that the area of the upper circular segment it is equal to the area of sector NOL this is sector NOL minus the area of triangle NOL and the area of the length equals to the area of circular segment NL, the upper circular segment NL, plus the area of the lower circular segment NL. Actually, the lower circular segment NL, this is the lower circular segment NL. This is the lower circular segment NL. Okay, so we have to add the area of the lower circular segment here in the lower circular segment NL. The area of the lower circular segment NL equals to the area of sector NLM this is sector this is sector NLM plus minus the area of triangle NML. I repeat again that the area of the lower circular segment NL in the orange color equals to the area of sector NML minus the area of triangle NML. And we have already found out that the areas of the two sectors actually found out that the area of the first sector NOL it is equal to theta A squared plus the area of the second sector sector NML equals to pi b squared over 2 minus theta b squared, and we have to subtract from the sum of the areas of those two sectors the sum of the areas of those two triangles. Okay? So what is left to do here is to find out the areas of those two triangles. In order to find out the area of the two triangles, we'll combine them together . So we combine the two triangles together and created a quadrilateral NOLM. This is quadrilateral NOLM. In the next step, we'll join points O and M together by a straight line. By joining points O and M by a straight line, we created here two right triangles. So we'll find out the area of those two right triangles, we will add the two areas together, and this will be the sum of the areas of the two original triangles. Okay. The area of the green right triangle equals to a times b over 2 is the I times the base times the I to the base over 2, that is 8b over 2, and the area of the orange right triangle equals to a times b over 2. Also, you add the two areas together, so it is a times b over 2 plus a times b over 2, that is 2 times a times b over 2. We have 2 in the denominator, so 2 will get cancelled. So in conclusion, we found out that the sum of the areas of the two triangles it is equal to a times b. And so the sum of the areas of those two triangles it is a times b. So in conclusion, we found out that the area of the length, that could be any length, is equal to theta times a squared plus pi b squared over 2 minus theta times b squared minus ab. Also we found out the area of the length that could be any length. Okay. So here we take theta as a common factor of those two expressions. So what is left from this expression after we took from theta as a common factor? What is left is actually a square. And what is left from this expression after we took from theta as a common factor? What is left? It is actually minus b squared. And we have also to add pi b squared, this expression, over 2 minus ab. So the area of this length, that could be any length, equals to this expression. In the next step, we will find out the value of theta itself. We actually want that the only basic variable that will be in the formula for the area of the length will be only the radii of the two shapes. Therefore, we want to eliminate theta here. So in order to find out the value of theta, I will draw the right triangle NML that contains angle theta. This is the right triangle NOMO. This right triangle NOM. We know that tangent theta equals to NM over NO. Tangent theta equals to NM over NO. NM equals to B. NO equals to A. So in conclusion, we found out that tangent theta equals to B over A. We want to find out the value of theta itself. Therefore, in order to find out the value of theta itself, we will operate the opposite function of tangents on the result, BA, and this will give us theta itself. So the opposite function of tangents is tangents minus 1, and we will operate the opposite function on the result B over A, and this operation will give us the value of theta itself. Okay. Conclusion, we found out that theta equals to tangents minus 1, that is the opposite function of tangents, on B over A. Now we can substitute theta by tangents minus 1 over B over A, tangents minus 1 of B over A. We do it now and we get that the area of the lens, that could be any lens, it is equal to theta is tangents minus 1 of B over A, and there we will multiply it by A square minus B square, plus pi B square over 2 minus AB. Okay. So actually we found out the general formula for the area of any lens. I'll copy the general formula for the area of any lens. On this new page, and we'll use the general formula in order to find out the area of the blue lens and also the area of the big lens. So I repeat again. Here we found a general formula for the area of any lens. And we'll use this general formula for the area of a lens in order to find out the areas of the blue lens and the area of the big lens. Here we'll find out the area of the big lens and also the area of this blue lens by using this general formula that is good for any lens. First of all, we find out the area of the big lens. This is the area of the big lens. So the area of the big lens will be equal to, first of all, we have to find out how the big lens was created. The big lens is created by the intersection of the quarter circle with this semicircle. And therefore, we have to find out the radius of the quarter circle and also the radius of the semicircle. From this drawing, it is very easy to see that the radius of this quarter circle it is equal to 10 units. So A equals to 10 units, while the radius of this semicircle, what is the radius of this semicircle? We know that the diameter of this semicircle equals to 10 units. Therefore, the radius must be equal to 5 units. That is to say, B equals to 5 units. Okay, so we found out the values of A and B. Now we will put the values of A and B in this general formula, and we will find out the area of the big lens. So we get here that tangents minus 1 B is 5, A is 10, so 5 over 10 is 1 half, 1 half is 0.5 times A square minus B square. A is 10, so A square is 10 square minus B square. B is 5, so B square is 5 square. Plus pi, B is 5, so B square is 5 square over 2 minus A times B. A is 10 and B is 5. So it is minus 10 times 5. So the area of the big lens equals to, here 10 square is 100, 5 square is 25, and 100 minus 25 is 75. So it is 75 times tangents minus 1 of 0.5. Here 5 square is 25. 25 over 2 is 12.5. So in conclusion, in total, this expression equals to 12.5 pi. Minus 10 times 5 is minus 50. So in conclusion, I found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50 square units. In the next step, we will find out the area of the blue lens, and then we will subtract the two areas from each other, This will give us the area of the orange shape that we are looking for. So here, what is the area of the blue lens? The area of the blue lens according to this general formula. First of all, we have to find out here how the blue lens was created. This blue lens was created by the intersection of those two semicircles with each other. The common area is the blue lens that we are looking for, and the blue lens is created by the intersection of those two semicircles with each other. And we know that the radius of each semicircle equals to 5 units because the diameter is 10. So here A equals to 5 and B also equals to 5 because the radii of the two semicircles are equal. They are both equal to 5 units. Now we'll put the values of A and B inside the formula for the area of a lens, and we'll find out the area of this blue lens. We get that the area of the blue lens equals to tangents minus 1 B is 5, A is 5, and 5 over 5 is 1. Tangents minus 1 of 1 times A square minus B square. A is 5, so A square is 5 square. Minus B is 5 also, so it is also 5 square. Five square minus 5 square is 0. So this expression equals to 0. Plus pi b square over 2. B is 5, so b square is 5 square. So it is pi 5 square over 2 minus AB. A is 5, B is 5, so A times B is 5 times 5, that is 25. So in conclusion, we found out that the area of the blue lens, this blue lens, it is equal to 5 square is 25, 25 over 2 is 12.5, so this expression in total equals to 12.5 pi minus 25. And that is actually the area of the blue lens. Now we'll subtract the two areas from each other, and this will give us the area of the blue lens, the area of the orange shape. The area of this orange shape. I'll repeat again. The area of the orange shape equals to the area of the big lens minus the area of the blue lens. That is to say, the area of the orange shape equals to the area of the big lens, that is actually equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. This is the area of the big lens minus the area of the blue lens. So it is minus the area of the blue lens equals to 12.5 pi minus 25. Here we'll open the brackets and we get here 75 tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Here we'll open the brackets here, so it is minus 12.5 pi. Minus is plus, so it is minus 25 is plus 25. So here we have 25 pi, 12.5 pi minus 12.5 pi is 0, and minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the green shape equals to the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. So here we actually know that tangents minus 1 of 0.5 equals to 0.46. Therefore, we multiply 75 we multiply 75 by 0.46, we subtract 25, and you'll get that the area of the orange shape equals to 75 times 0.46 is 34.77 minus 25, it is equals to 9.77 square units. Okay, found out that the area of this orange shape dpq, it is equal to 9.77 square units. We finished with the first method. In the next step I present you the second method. So I've already mentioned, in the second method, we will not use any general formula for the area of a lens, but we will directly calculate the area of the big lens. We will calculate the area of this blue lens. We will subtract the two areas from each other, and this will give us the area of this orange shape. Okay, so we'll start. First of all, we'll find out the area of this blue lens that was created by the intersection of the two semicircles with each other. So our mission is to find out the area of the blue lens. This is the blue lens, and we find out the area of this blue lens. So finding out the area of the blue lens. We have already found out that when the two semicircles intersect with each other, we have all the things here that we have already found out. In our specific case, we know that the radii of the two semicircles are equal to each other. They are both equal to 5 units. So here A will be equal to 5 and B will be equal to 5. Okay? You can use this drawing because here we found out the area of this lens that could be any lens, and this lens was created by the intersection of two semicircles with each other. So if we assume that A equals to 5 and B equals to 5, this will be the area of the blue lens. This will give us the area of the blue lens when we will determine that A equals to 5 and B equals to 5. We can use this drawing because if we determine that A equals to 5 and B equals to 5, this will be exactly suitable for our two semicircles. That's the radius of each semicircle. It is equal to 5 units. So OL equals to A, but A equals to 5. ON equals to A equals to 5. This angle equals to 90 degrees. OM NM equals to 5. ML also equals to 5. This angle equals to 90 degrees. Is a right angle. Here, because of the fact that the radii of the two semicircles are equal, they are both equal to 5 units. It means that those two circular segments will be identical, and therefore we can multiply the area of this circular segment by 2. This will give us the area of the whole length, that is the blue length. Okay. So first of all, we will find out the area of the upper circular segment. We will multiply it by 2, and this will be the area of the blue length. I remind you that our mission now is to find out the area of the blue length. So what is the area of this blue length? The area of this blue length NL will be equal to the area of sector NOL This is sector NOL minus the area of triangle NOL. Okay, this is triangle NOL. And if you subtract the area of triangle NOL from sector NOL, you will get exactly the area of this upper circular segment. And then we will multiply this area by 2, and this will give us the area of this blue length. So what is the area of sector NOL? The area of sector NOL, you can see that sector NOL is a quarter circle. Because this angle equals to 90 degrees, therefore sector NOL is a quarter circle. And we know that the area of any quarter circle equals to pi r squared over 4. R equals to 5, so it is pi times 5 squared over 4. And the area of the right triangle NOL will be equal to the base of the triangle, that is 5, times the height to the base, that is also 5, over 2. Okay, so this is the area of circular segment NL. Okay, now we have to multiply the area of circular segment NL in order to find out the area of the blue lens. So the area of the blue lens of this blue lens will be equal twice, 2 times the area of this circular segment. So it is 2 times pi times 5 square over 4 minus 5 times 5 over 2. So here we will open the brackets and we will get that two times pi 5 squared is 25 over 4 equals to minus 2 times 5 times 5 over 2. So here we divide this expression, both the numerator and the denominator, by 2. So 2 over 2 is 1, so in the numerator we left only with 25 pi. Here 4 over 2 is 2, so in the denominator we left with 2. Minus, we have here 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And 5 times 5 is 25. So in conclusion, we found out that the area of the blue lens it is equal to 25 over 2 is 12.5. So in conclusion, this expression equals to 12.5 pi minus 25. Okay. So the area of the blue lens equals to 12.5 pi minus 25 square units. We finished with the first step. In the next step, we'll find out the area of this big lens. Actually, this big lens was created by the intersection of this quarter circle with the semicircle. So here I write down that our mission is to find out the area of the big lens. find out this area. Okay. Here the radius of the big of the quarter circle equals to 10 units. So here we define the center of this semicircle is point O. This is point L. Point O is the center of the semicircle, point L is the point on the semicircle itself, therefore OL is the radius of this semicircle that is equal to 5 units. We define the center of the quarter circle as M. Point M is the center of the quarter circle, point L is the point on the quarter circle itself, therefore ML is the radius of the quarter circle that is equal to 10 units. We will join the two centers together, the center of the semicircle and the center of the quarter circle. Point N is a point on this semicircle. Again, point O is a point O is the center of this semicircle, and point N is a point on the semicircle itself. This is exactly the definition of a radius. So 9/7 NO is the radius of this semicircle that is equal to 5 units. So here the radius NO of the semicircle is tangent to this quarter circle. So point N is the point of tendency. The point of tangency of tangent NO with this quarter circle. And we have the radius MN that is drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tendency of tangent ON with this quarter circle. Whenever you have a radius that is drawn to the point of tendency, then tangent ON will be perpendicular to the radius NM. So if ON is perpendicular to NM, it means that this angle equals to 90 degrees. Here, the radius OL is tangent to the quarter circle point L. Point L is the point of tangency of tangent OL with this quarter circle. And we have the radius ML of the quarter circle that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent OL with this quarter circle. Whenever you have a radius that is drawn to the point of tendency, then tangent OL will be perpendicular to the radius LM. So if OL is perpendicular to LM, it means that this angle equals to 90 degrees. Okay. Here we will join points N and L together by a straight line. So the straight line NL divides the big length into two parts. This is the upper circular segment and this is the lower circular segment. We will calculate the area of each part, and then we will add the areas of the two parts, the two circular segments to each other. This will be the area of this big length. In the first step, we'll calculate the area of the upper circular segment of the big length. Okay? We'll also define angle OMN as theta. Those two right triangles can go into each other according to side rule. Here, triangle ONM can go into triangle OML according to side rule. I will show it why they can go into each other. Here, those two sides are both equal to 10 units, therefore they are equal to each other. Those two sides they are both equal to 5 units, therefore they are equal to each other. And finally, OM is the common side that belongs to both triangles, therefore this side equals to itself. So we actually proved that those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we conclude that those two angles are equal to each other according to the rule that corresponding angles that can go in triangles are equal to each other. Okay, so we know that those two angles are equal to each other. So if this angle equals to theta, it means that this angle must be also equal to theta. Okay, because they are equal to each other. So this angle equal to theta. Okay. And in the right triangle NMNO, this angle equal to theta. This angle equals to 90 degrees, that is pi over 2 in terms of radians. So the missing angle must be equal to 90 degrees minus theta in terms of degrees. In terms of radians, it is pi over 2 minus theta. Likewise, if we focus, actually, those two angles are equal to each other because of the fact that those two triangles can go into each other. But you can also see that this angle equals to theta, this angle equals to 90 degrees of pi over 2, therefore this angle must be equal to pi over 2 minus theta. Okay? So what is the area of the upper circular segment NL? The area of the upper circular segment NL of the big lens it will be equal to the area of sector NML. This sector So this is sector NML that I copied from the original drawing, minus the area of triangle NML. This is triangle NML. It is very easy to see from the drawing. If you subtract the area of triangle MNL from the area of sector NML, you will get exactly the area of the upper circular segment NL. Okay? And we have already found out that the angle between the legs of sector and ML, it is equal to 2 theta. The sector and ML, this is circular segment. NL, the upper circular segment NL. Okay, upper circular segment. And the area of the upper circular segment equals to the area of sector NML minus the area of triangle NML. So the area of sector NML equals to 2 theta over 2 pi times the area of the circle. Here NM equals to 10. It is pi r squared and r equals to 10. So it is pi 10 squared. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So this expression, the area of the sector NML, will be equal in total, 10 squared is 100, so it is 100 times theta. 100 theta. Now we'll find out the area of triangle NML. So it is minus the area of triangle NML. NM equals to 10, LM equals to 10 units. And then again, between the sides NM and LL, NM and LM is 2 theta. Therefore, the area of triangle NML will be equal to NM times ML times sinus 2 theta over 2. NM is 10, ML is also 10, times sinus 2 theta over 2. Okay? So here we get that the area of the upper circular segment NL is equal to 100 times theta minus, here 10 times 10 is 100 and 100 over 2 is 50. So in total this expression equals to 50 times sinus theta, sinus 2 theta. Okay? So this is the area of the upper circular segment NL. Hundred times theta minus 50 times sinus 2 theta. In the next step, we will find out the value of theta and the value of sinus theta, and we will substitute theta by the value that we will find, and we will substitute sinus 2 theta by the value that we will find. So we start with the mission. In order to find out the values of theta and sinus 2 theta, I will draw here the right triangle M and L that consists angle theta, and we will find out the two values from the triangle. So this is triangle NOL, NOM, as I copied from this drawing, and M equals to 10, NO equals to 5. This is triangle NOM. This is angle theta. Here, tangents theta in triangle NOM, tangents theta equals to NO over NM. NO is 5 and M is 10, so in conclusion we found out that tangents theta equals to 5 over 10, that is 1/2, that is 0.5. Now theta itself, in order to find theta itself, we will operate the opposite function on the result, that is 0.5, and this will give us the value of theta itself. So theta, angle theta itself equals to tangents minus 1, that we operated that is opposite function of tangents that will operate on the result, that is 0.5, and this will give us the value of theta. We found out the value of angle theta. In the next step we'll find out the value of sinus 2 theta. So I'll copy the right triangle again here. The right triangle NOM. We'll find out the value, the length of the hypotenuse MO by implementing the Pythagoras theorem on the right triangle NOM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO squared equals to NO squared, that is 5 squared is 25, plus NM squared. NM is 10, so NM squared is 10 squared, that is 100. So MO squared equals to 25 plus 100 is 125. Here we take out of this equation and we find out that MO equals to the square root of 125. 125 equals to 25 times 5. We take out of this expression and we find out that the square root of 25 is 5, so inside the root we left only with 5. So in conclusion, the hypotenuse MO equals to 5 times root 5. The hypotenuse equals to 5 times root 5. Sinus 2 theta equals to 2 times sinus theta cosine theta. So sinus 2 theta equals to 2 times sinus theta. From this triangle you can see that sinus theta equals to NO over OM. Sinus theta equals to NO over OM. NO equals to 5. OM equals to 5 times square root of 5. So in conclusion, sinus theta equals to 5 over 5 times square root of 5 times cosine theta. So from this triangle, the right triangle NOM, it is very easy to see that cosine theta equals to NM over MO. Cosine theta equals to NM, that is 10, over MO, that is 5 times square root of 5. So in conclusion, cosine theta equals to 10 over 5 times square root of 5. Here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So in the numerator we have 2 times 10 over square root of 5 times square root of 5 is 5 times 5. Here 10 over 5 is 2. So here 2 times 2 is 4 over 5. So in conclusion, we found out that sinus 2 theta equals to 4/5 while tangents minus 1 of 0.5 it is equal to theta. Theta equals to tangents minus 1 of 0.5 and we have already found out that the area of the upper circular segment NL of the big lens equals to 100 times theta minus 50 times sinus 2 theta. Okay, now we'll substitute theta by tangents minus 1 of 0.5, and we'll substitute sinus 2 theta by 4/5. And we'll get that the area of the upper circular segment of the big lens, NL, it is equal to 100 times theta, and theta equals to tangents minus 1 of 0.5 minus 50 times sinus theta, and sinus theta equals to 4/5. So here it is equal to 100 times tangents minus 1 of 0.5 minus 50 over 5 is 10, and 10 times 4 is 40, so it is minus 40. In conclusion, we found out that the area of the upper circular segment NL of the big lens, it is equal to 100 times tangents minus 1 of 0.5 minus 40. Okay, we finished with the upper circular segment. In the next step, we'll find out the area of the lower circular segment, and then we will add the two areas together. This will give us the area of the big lens. Okay. Now our mission is to find out the area of the lower circular segment of this big lens. The area of this lower circular segment, now the green shape, that is the lower circular segment of the big lens. Okay. So we copy all the things that we have already done to find out the area of the upper circular segment. We have already found out that angle N or M, this angle equals to pi over 2 minus theta, and this angle also equals to pi over 2 minus theta. So the sum of those two angles is the size of angle NOL. So the size of angle NOL equals to the pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of angle NOL, this angle, it is equal to pi minus 2 theta. In terms of radians, of course. Okay. So what is the area of the lower circular segment NL? The area of the lower circular segment of the lower circular segment NL will be equal to the area of sector NOL, this sector, minus the area of triangle NOL, this triangle. I repeat again, the area of the lower circular segment NL equals to the lower circular segment of the big length equals to the area of sector NOL, this sector, minus the area of triangle NOL. Triangle NOL. So the area of sector NOL equals to the angle between its legs is pi minus 2 theta over 2 pi times the area of the circle, that is pi r squared, and r equals to 5, so it is pi times 5 squared. We have theta in the numerator and theta in the denominator, so theta will, pi in the numerator and pi in the denominator, so pi will get cancelled. Here we'll open the brackets and we'll get that 5 squared is 25, so it is 25 pi over 2. 25 pi over 2 minus, here it's 25 theta times 2 over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, we found out that the area of sector NOL equals to 25 over 2 is 12.5. So this expression in total, it is equals to 25 pi minus, we have 2 in the numerator and 2 in the denominator, so it is 2 will get cancelled, so it is 12.5 pi minus 25 times theta. And we have to subtract also triangle NOL. To subtract the area of triangle NOL from this sector NOL. The area of triangle NOL equals to the multiplication of the sides of the two sides of each other. It is 5 times 5 times sinus pi minus 2 theta over 2. Okay. So the area of the lower circular segment NL equals to 12.5 pi minus 25 theta. Here we have 5 times 5 is 25, so it is 25 over 2, and sinus pi minus 2 theta equals to sinus 2 theta. And we have already found out that sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5. So the area of the lower circular segment NL of the big lens it will be equal to 12.5 pi minus 25 times theta, and we already found out that theta equals to tangents minus 1 of 0.5, so we substitute theta by tangents minus 1 of 0.5 minus 25 over 2 times sinus 2 theta, and we already found out that sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5. So in conclusion, we found out that the area of the lower circular segment NL it is equal to 12.5 pi minus 25 tangents minus 1 of 0.5. Here we have 25 over 5 is 5, and 5 times 4 is 20, and 20 over 2 is 10, so it is minus 10. So in conclusion, we found out that the area of the lower circular segment NL equals to 12.5 pi minus 25 times tangent theta of 0.5 minus 10. Now we will add the upper circular segment of the big lens to the lower circular segment, and we will find out the area of the big lens. Okay, so the area of the big lens equals to the area of the upper circular segment NL plus the area of the lower circular segment NL. Okay, we will add the two areas together and we will get the area of the big lens. Okay, so the area of the big lens equals to the area of the upper circular segment, it is 100 times tangents minus 1 of 0.5 minus 40 plus the area of the lower circular segment, that is equal to 12.5 pi minus 25 times tangents minus 1 of 0.5 minus 10. Okay, so in conclusion, we found out that the area of the big lens equals to 100 times tangents minus 1 of 0.5 minus 25 tangents minus 1 of 0.5 equals to 75 times tangents minus 1 of 0.5, and we have here minus 40 minus 10 is minus 50 plus 12.5 pi. So this expression is the area of the big lens. We have already found out that the area of the blue lens equals to 12.5 pi minus 25. So the area of the big lens minus the area of the blue lens will give us the area of the orange shape. Okay. Repeat again that the area of the orange shape equals to the area of the big lens minus the area of the blue lens. And we have already found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5, and the area of the blue lens equals to 12.5 pi minus 25. So here we'll open the brackets and we get that the area of the blue, the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Here we'll open the brackets and we get minus 12.5 pi. Minus and minus is plus, so it is plus 25. So here we have 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled. And we have minus 50 plus 25 is minus 25. So in conclusion, I found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. Okay. This is the area of the orange shape that you're looking for. We know that tangents minus 1 of 0.5 equals to 0.46. So we have to multiply 75 by 0.46. We'll subtract 25 and we'll get the area of the orange shape. So we get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5, and tangents minus 1 of 0.5 equals to 0.46. So we substitute tangents minus 1 of 0.5 by 0.46 minus 25. And 75 times 0.46 is 34.77 minus 25. And 34.77 minus 25 is 9.77 square units. So we found out that the area of the orange shape that we are looking for, it is equals to 9.77 square units. Okay, so now I'll summarize the lecture. Okay. So in the drawing we have square ABCD. One side of square ABCD equals to 10 units. Inside square ABCD we have two semicircles that intersect with each other and create the blue length. In addition, we have also the quarter circle that intersects with this semicircle and creates the big length. And our mission is to find out the area of this orange shape. And it is very easy to see from the drawing that the area of this orange shape equals to the area of the big lens minus the area of the blue lens. Okay? So, I presented to you two different methods that we'll use in order to find out the area of this orange shape. In the first method, we will create a general formula for the area of any lens, and then we'll use the general formula that we created in order to find out the area of the blue lens. We'll use the same formula in order to find out the area of the big lens. We'll subtract the two areas from each other. This will give us the area of this orange shape. This will be the first method. In the second method, we will directly find out the area of the blue lens, then we will directly find out the area of this big lens. We will subtract the two areas from each other, and this will give us the area of the orange shape. Okay? So here I presented to you what is the area of a sector. The area of a sector equals to the ratio between the angle between his legs, that is theta here, over 2 pi. The 2 pi radians is 360 degrees. The ratio between the two legs gives us the percentage, the relative percentage that this sector occupies out of all the sector, or out of all the circle, and when we will multiply it, this percentage by the area of this circle, this will give us exactly the area of this sector. So theta over 2 pi times pi r square equals to A. Then I presented to you the second concept, that is the area of a circular segment. The green shape, it is equals to the area of sector AOB minus the area of triangle AOB. Okay? Then, so I already mentioned the general idea how to solve the question is that the orange shape equals to the area of the big lens minus the area of the small lens. The area of the big lens minus the area of the small lens will give us the area of the of the orange shape. Okay? So in the first method, we actually found the area of a lens. It could be any lens, and then we subtracted it in the first method. We found out the area of a lens, that could be any lens. In the first step, we found out the area of the upper circular segment. Then here, I repeat again that here we have here the two semicircles that intersect with each other, and they create this lens. We'll find out the area of this lens, and we'll use the formula in order to find out the area of the big lens, and then we'll use the same formula in order to find out the area of the blue lens, and then we subtract the two areas from each other. This will give us the area of the orange shape. So in the first step, we find out the area of the this lens, that will give us the formula for the area of any lens, that we'll use later in order to find out the areas of the big lens and the area of the blue lens. So here we have two semicircles that are perpendicular to each other, and they create this lens that is the common area of the two semicircles. That is to say, this lens is the area that belongs to both semicircles. Okay? So here we divided this lens into two parts. In the first step, we found out the area of the upper circular segment. In the second step, we found out the area of the lower circular segment. We add the two areas together. This gave us the area of this lens, that could be any lens. So here, in the first step, we calculated the area of this upper circular segment NL. What is the area of the upper circular segment NL? Is equal to the area of sector NOL minus the area of triangle NOL. It's very easy to see that if you subtract the area of triangle NOL from the area of sector NOL, we will get exactly the area of the circular segment NL. So what is the area of sector NOL? Is equal to the angle between the legs of the sector times pi s squared over 2 pi. This gives us the result that the area of this sector NOL equals to theta a squared. We didn't calculate the area of this triangle because we calculated the sum of the areas of the two triangles in a different way. So we finished with the upper circular segment, then we found out the area of the lower circular segment of the lens, that could be any lens. It is equal to the area of this sector minus the area of triangle NML. And we found out that the area of sector NML equals to pi b squared over 2 minus theta b squared. Okay, then we added the two areas together, and the sum of the areas of the two circular segments gave us the area of this lens, that could be any lens. So the area of the lens equals to the sum of the areas of the two circular segments, the upper circular segment and the lower circular segment. Okay? So the area of the lens equals to the sum of the areas of the two sectors minus the sum of the areas of the two triangles. In order to find out the area of the two triangles, we combined them together. We created a quadrilateral NMOL. Then we joined points O and M together by a straight line. By joining points O and M by a straight line, we created here two right triangles. We calculated the areas of the two right triangles. The sum of the areas of the two right triangles is AB. We concluded and found out that the sum of the areas of those two right triangles is A times B. So we have to subtract from the sum of the areas of those two sectors the sum of the areas of those two triangles, that is AB. So we subtracted from this sum AB, and this is the area of this lens, that could be any lens. So in conclusion, we found out that the general formula for the area of a lens, it is equal to this expression, and we used this formula in order to find out the area of the big lens. We used the same formula in order to find out the area of the blue lens. We subtracted the areas from each other, and we found out that the area of the green shape equals to the area of the big lens minus the area of the blue lens. And the final result is that the area of the blue lens equals to 9.77 square units. Finish with the first method. Then in the second method, we calculated the area orange shape by calculating the area, directly the area of the big shape. We calculated also the area of the blue shape. We subtracted the two areas from each other, and that gave us the area of the orange shape. So first of all, we calculated the area of the blue shape. So here, we actually used the method 1 here, because in method 1 we have the intersection of those two semicircles with each other. Here the radius of the first semicircle was A, so here A equals to 5, and the radius of the second semicircle was B, here B equals to 5 units. Okay, because the radii of the two semicircles is created by intersection. The radii of those two semicircles, they are both equal to 5 units because of the fact that the diameter of each semicircle equals to 10. Therefore, the radii of those two semicircles, they are both equal to 5. Okay, so first of all, we calculated the area of the upper circular segment, and then we multiplied by 2 in order to get the area of the blue lens, because of the fact that those two circular segments are identical, so we can multiply the area of one circular segment by 2, and this will give us the area of the blue lens. So we actually calculated the area of the upper circular segment. The area of the upper circular segment equals to the area of sector NOL minus the area of triangle NOL. Triangle NOL is a quarter, sector NOL is a quarter circle, therefore its area equals to pi r squared over 4. The area of this right triangle is the multiplication of the two sides over 2. So this is the area of the upper circular segment. We multiplied the area of the upper circular segment by 2 and found out the area of the blue lens. In the next step, we found the area of the big lens that was created by intersection of the quarter circle with this semicircle. First of all, we found out the area of the upper circular segment of the big lens. Here. The area of the upper circular segment of the big lens equals to this expression. In the next step, we found out the area of the lower circular segment of the big lens. Found out that the area of the lower circular segment of the big lens equals to this expression. And the total area of the big lens equals to the area of the upper circular segment plus the area of the lower circular segment, that is equals to this expression. Then we already found out that the area of the big, so this is the area of the big lens, this expression. We have already found out that the area of the blue lens equals to this expression. Then we subtracted the two areas from each other. Here the area of the orange shape equals to the area of the big lens minus the area of the blue lens. So we have, this is the area of the big lens. This expression equals to the area of the blue lens, we subtracted the two areas together, and finally we found out that the area of this blue lens equals to 9.77 square units. Repeat again that the area of this lens according to the second method equals to 9.77 square units. So in both methods we arrive to the same result. So I'll repeat again that in the first method we created general formula for the area of any lens. Then we use the general formula for the area of any lens in order to find out the area of the big lens. Then we use the same formula in order to find out the area of the big lens. We subtracted the two areas together from each other. In this way we got the area of this orange shape. In the second method we directly calculated the area of the big lens, we directly calculated the area of the blue lens, and we subtracted the two areas from each other, and this gave us the area of this orange shape. Okay? Thank you very much.